Okay, welcome to Biohacking Beauty, the podcast that brings all the science of longevity and translates it to skin health. I'm Amitai Eshel. This is
Anastasia Khojaeva.
And we are the co-founders of
Young Goose Skincare.
Yeah, which is the world's first biohacking longevity skincare. And today we have a very special episode. We're going to talk about one of the hottest subject that we were pioneers of, I would say. Mm-hmm. But before that, we're going to read a review.
Okay. I found the perfect review for you. It's short and sweet.
And Anastasia wants to conserve her voice, so I'm going to be reading the review. Every week, we're reading a review of one of the people who listen to this podcast, and the reason is because reviews really allow us to basically be more discoverable, and that means we can help more people, provide the information that we believe people need to hear in order to have better skin. So we give back. If we read your review, you're gonna get a free product from us. So you text us on Instagram, or you write an email to service@younggoose.com, and we're sending you a free product. And the review today is by a person called Dar Queen Biohacker. Truly aging in reverse. She's saying, I'll hit 60 in just a few months and consistently have ladies ask me what I do for my skin. I have never done fillers or had plastic surgery and have used Young Goose for at least 3 years religiously. I love how the company continues to invest in their product line and continues to bring transformation in a bottle. And I'm assuming the fact that she listens to this podcast helps as well, because you get information that you can apply. But Anastasia, I want to start with a number today.
Okay, hit me with the number.
Okay, by middle age, by the time you're 45, 50, you've lost half of a molecule that basically runs your entire skin. Half. Gone.
Yeah. Crazy. And it gets worse than that, believe it or not, because the enzyme your skin uses for DNA repair, which is PARP1, consumes up to 90% what's left in a single UV exposure of that molecule. So you're starting with the half, and one afternoon in the sun, just, had a walk in the sun, and it nearly wipes out the rest.
The molecule, if you guessed it or you read the title of this episode, the molecule is NAD+. And today we're tearing this thing apart, what it does, why it disappears, and exactly what you can do about it, right? So, Ready?
Let's get into the data. And I want to also say that it's one of the most requested podcast episodes. We did extensive research, and we're going to have citations for all of the articles we put together to provide you guys the most up-to-date scientific information.
Yeah, well, we've been living and breathing, no pun intended, we've been living and breathing this molecule, especially as it applies to skin for the last...
Yeah, it's easy for us because we're anyway up to date. Yeah. But I'm excited to, and we've recorded podcasts on NAD Plus in the past. You can refer to them. They're still accurate. But what's exciting is that the field, as you mentioned in the beginning of this podcast, now the field invests so much into research on NAD Plus. So you get more and more and more discoveries. And, that's why we also have been changing some of the things we're doing and how we're approaching working with this molecule. But now let's talk about why it matters for the skin.
Okay. So, Anastasia, NAD+, I always describe it as a rechargeable battery inside every cell. And, because what it really does, picks up energy from food, delivers it to mitochondria. And without it, your cells just go dark. The analogy we give a lot is if we took it away from the body magically, you're going to die in 30 seconds. But is this an oversimplification?
Yes, it is. And I'll tell you why. The fact that the analogy of rechargeable battery, it's a good one. It's a good starting point, but it really undersells the scope of what that molecule does. So NAD plus participates in over 500 enzymatic reactions. It's not just an energy shuttle. It's one of the most versatile molecules in human biology. It handles both glycolysis and the mitochondrial electron transport chain and many, many other reactions. So the battery captures part of it, but it's more like an electrical grid because it functions as a substrate. So it effectively is being consumed, which the battery part is not touches on it, does not touch on it.
So somewhere it's like a hybrid between like a battery and a jar of cookies. No, but 500 reactions, that's crazy. Okay, so it isn't a supporting player, right? It's more of a major, the main role in skin aging and in aging is in general. But here's what I think most people miss. NAD, and when we say NAD, we just leave out the plus part. So it's the same thing when we talk about. So NAD doesn't just carry energy, right? As you said, it gets consumed. It gets used up or destroyed. And that's where the aging story starts, right?
Exactly. There are 3 families of enzymes that consume NAD plus as a substrate. The first one, the one that most biohackers heard about, is Sirtuin through Sirt7. These are NAD plus dependent deacetylases, which is just a fancy way of saying that their job is removing the acetyl group. And every time they remove the acetyl group from a target protein, such as P53 or NF-kappa B, they break down one NAD plus molecule. They're essential for DNA repair, inflammation control, and cellular survival. So essentially, we are paying with NAD plus for those processes: repair, inflammation control, cellular survival.
So what you're saying is that every repair job, every time your body calms inflammation down or creates collagen, it's burning through NAD to do it.
Exactly.
Right?
Exactly.
Like paying a toll.
Yes.
Basically, every time you cross a bridge.
Yeah, and when you mentioned the battery analogy, that feels like, oh, it's just a battery. We can always refill. We can always recharge. But when you understand that it's getting used up, then you kind of can already start seeing the picture of how it declines over time.
Yeah. So what about the second family?
Yeah. So the second family, PARPs, which stands for poly-ADP ribose polymerases. PARP1 is the one that matters most for skin. When UV light breaks down DNA, PARP1 builds scaffolding to recruit repair proteins. A single significant UV exposure can deplete up to 90% of that cell's NAD+. So that skin cell, NAD+, remember, NAD+ is responsible for so many important processes. Boom, 90% are gone because you've undergone significant UV exposure.
Yeah, so one sunburn, basically. That's crazy. And sometimes I refer to Sirtuins, which you mentioned, Sirt1 to Sirt7, like the police of your cells, of your DNA expression. PARPs are more like the fire brigade, right? So imagine if you have like a fire, right? Who's going to get the precious gas, right? You're not going to give it to the police. You're going to give it to the fire department because they need to extinguish the fire. But on the other hand, during many fires, there are lootings, right? So you're basically starving the police. You're basically starving that normal, orderly kind of behavior from DNA expression.
You defend the police, and you don't want to do that.
Yeah, exactly. So then there's CD38, which is which you've talked extensively about before. We talk a lot about it, probably off camera most, but we talk a lot about it. And this is I would say, like the villain of the story. An enzyme that just devours, I call it NAD Pac-Man, it just devours NAD constantly, and it gets significantly worse with age. We're going to come back to CD38 in the to later on in this episode, because it's the key to the whole gradual decline with age.
Yeah, right. And the other side of this equation is replenishment. So your cells recycle NAD plus through the salvage pathway, which handles about 85% of turnover. The rate-limiting enzyme is NAMPT. Every time we mention it on the podcast, I always stutter. It converts leftover nicotinamide back to NMN, which then becomes NAD+. The speed of NAMPT determines the ceiling on your NAD+ production. And this is very crucial.
Yeah, and here's the double hit there. NAMPT drops, the amount of NAMPT, that enzyme, drops with age. So you're burning through more NAD while recycling or making less of it. So your paycheck is shrinking, but your bills, they keep going up, right?
Yeah.
So Anastasia, when you look at skin specifically, what are the effects, or what are the downstream consequences of everything that we've discussed?
Yeah, it's a multi-system crisis, really. So fibroblasts need NAD plus for Sirtuin-mediated collagen production, keratinocytes needed for PARP1 DNA repair, stem cells needed for ATP to divide. And critically, the timing of all of these processes depends on NAD plus oscillators tied to the circadian clock. So it's not one pathway. It's an interconnected network with NAD plus right at the center.
That's the part that I feel that I want people to really hear, right? I want to make a shirt, the anti-social club. I want to make some shirt. I don't have the right phrasing, but a shirt about like anti-single molecule companies. Many companies saying, hey, this thing is going to solve all your problems. This is all you need in your products. Yeah. And I'm against it. And this is why, we're not specifically like an NAD skincare company, even though we were the first ones to introduce NAD into skincare. And within our discussion right now, we are talking about a single molecule, but many different mechanisms. That's the part I want people to hear. It's not some trendy supplement ingredient. NAD is the molecule every skin cell depends on. By the way, every skin cell depends on for every function that keeps you functioning younger or looking younger. So when it drops, or looking young, by the way, in general. So when it drops, everything drops with it.
Yeah. Do you want to quantify the decline?
Yeah, let's quantify the decline.
Because the numbers here really are alarming. So a 2012 plus one study by Missouri measured NAD plus across 45 human tissue samples from ages 0, so like newborns, to 97. Skin NAD plus in adults over 50 was up to 5-fold lower than in neonatal tissue. That's approximately 10 to 25% lost per decade after your 20s.
So 5 times lower, because normally we say, you lose 50% by that. No, you have 50% of what you need. You have 5 times lower, right? By the time you're in your mid 40s. Yeah. I remember the first time you showed me that paper, I thought it was like a typo. If your skin cells were like a bank or a bank account, you went from $100,000 to $20,000 in saving, like immediately, and the bills, they don't change. So
if anything, they go up.
They go up, exactly. So now talk about CD38, because this is where the story gets really stressful.
Yeah. So CD38 was identified in 2016 Cell Metabolism paper as the dominant NAD plus consuming enzyme in aging tissue. So it's an ectoenzyme on immune cell surfaces that hydrolyzes both NAD plus and NMN. its expression increases 2 to 3-fold with age. So you actually remember, you have less and less NAD+, and as some kind of like a bad joke, you actually make more of CD38 that consumes NAD+ with age.
Yeah.
So the mechanism behind that increases what's really fascinating.
This is the part that really blew my mind. You told me, I remember us having a conversation, you told me CD38 doesn't just like randomly go up. It has a close relationship with zombie cells or senescent cells, right?
Yeah.
To people who are newer to the podcast, these are damaged cells or older cells that instead of going through the normal process of elimination by the body, they stick around. And they don't. The reason they're called zombie cells is they don't just stick around. They also pump out inflammatory signals, and these activate macrophages, right? Which are those immune cells that we talked about, which crank out CD38.
Exactly. So, a 2020 Nature Metabolism study mapped the entire feed-forward loop. So, senescence triggers SASP. SASP activates macrophages. Macrophages express CD38. CD38 destroys NAD+, and low NAD+ accelerates further senescence. When they clear out senescent cells in genetically engineered mice that didn't have senescent cells in them, they preserved 60% more tissue of NAD+ over 6 months. But before everyone jumps to conclusions, I do want to point out that unfortunately, a lot of studies that look great in mice don't pan out in humans.
Yeah.
So this looks promising, and it has a merit to it, but let's not assume it's 1-to-1 in humans.
Got it. But there is a tight relationship between like more senescent cells and more CD30 or more senescent cells, more CD38 lowers NAD, lower NAD causes more senescence, and the cycle goes on, right?
Yes.
So as we say, it's a vicious cycle that feeds itself. But Anastasia, let's make this maybe more digestible. Yeah, more tangible. What does the person that's watching this or listening to this right now see in the mirror when all of this is happening or when they're going through this?
Yeah. So the first visible consequences is collagen loss. When NAD+ is insufficient, Sirtuin can't deacetylate P53 or suppress NF-kappa B, so collagen production genes slow down while MMPs, the enzymes that degrade collagen, get activated. So again, we're back into that cascade that's like very unfavorable, unfortunately, for our skin. So a 2024 study confirmed that restoring Sirtuin activity reversed these senescence markers in dermal fibroblasts.
So you're losing collagen faster while making less of it simultaneously, right? That's not just, I would say, like a gradual fade. Because a lot of the times we try to think of aging as this gradual process, but especially when we're talking about dysregulation or MMPs, it's more like a collapse, right? It's collapse happening beneath the surface before wrinkles even happen. So what else?
Let's talk about mitochondrial function. So SIRT3 needs NAD+ to deacetylate the antioxidant enzymes. Without it, oxidative stress builds in the mitochondria, and ATP output plummets.
Which means less energy for everything, right? So cell division, repair, barrier maintenance. That's why, older people's cellular turnover stretches from, 21 or 28 days to 50 or even 70 days, right? Older skin heals slower. It looks duller. It feels thinner. And we even know that people that have undergone a lot of like rejuvenation procedures to their skin, when they grow older, if they had not maintained longevity, and what we're talking about today, this is even exacerbated. So they did a lot of things to like maintain youthful looking skin, and then they get slower turnover and everything we're saying now, because they've caused more fires, that PARPs need to turn off, etc. That's even the reason that the barrier itself breaks down, right? We hear a lot these days about skin barrier and compromised skin barrier. That's a major player in skin barrier breakdown, right?
Mm-hmm. Yes. You're talking about the CD38 being the major player.
Well, I'm talking about the decline of energy in general. So, like, for example, anything that your cells need to do in order to maintain like skin barrier, whether it is ceramide synthesis, which would depend on NAD, enzymatic reactions, which would depend on NAD.
No, definitely. Depleted NAD plus weakens the stratum corneum lipid bilayer, increasing transepidermal water loss and sensitizing skin to irritants. And melanocyte regulation breaks down as well. So, you can no longer control the tyrosinase properly, leading to uneven pigmentation.
Yeah, I mean, I'm telling you, this tyrosinase, you gotta put it out of control. Anyway, so yeah, wrinkles, dullness, dryness, sensitivity, dark spots, all of it kind of traces back to the same root cause, which was this one molecule declining. I think, and we hear a lot about, we've heard a lot in the last, I don't know how many years in skincare. Oh, for pigmentation, you need to do this and that. For wrinkles, you need to do this and that. Well, at the bottom line, if you are not replenishing your mitochondria or replenishing NAD, you're only covering up symptoms. And I think that's why there is a real cult around NAD now, because it's so important.
Yeah. Let's do supplementation deep dive next. We'll talk about NMN, NR, niacin. So the encouraging part of this story is that NAD plus decline is reversible. There are 3 well-studied oral precursors, and they are not interchangeable. So, Amita, I know you have strong opinions here. Do you want to voice your opinions?
I do, but let's give people, data first, because that's why I have opinions there. So we'll let people decide, and I'm gonna stay quiet. But walk us through NMN, for example.
Okay, NMN. So NMN is nicotinamide mononucleotide, and it sits one enzymatic step from NAD+. In 2018, researchers found a dedicated transporter in the small intestine that specifically absorbs NMN. That direct route is unique among the precursors.
And that matters because it means NMN doesn't need extra conversion steps to enter your cells, right? Studies, again, like we're talking about studies that we've been looking at for the last decade or two. What we see a lot is that it reaches muscle, heart, brain, blood vessels, tissues like your skin depend on it for NAD supply, through circulation, right? Through basically having high levels of it throughout your body.
Right. Okay. So if we go back to the studies, a 2022 multi-center double-blind placebo-controlled trial in Neuroscience tested 300, 600, and 900 milligrams daily. So dose-dependent NAD plus elevation, no serious adverse events. But I want to flag a caveat. A 2024 Science Advances paper found most oral NMN actually gets converted to nicotinic acid by gut bacteria before absorption. So the pathway to NAD plus is more indirect than we initially assumed.
Yeah, to be honest, this paper surprised me. But I think the bottom line is that it's still the same. You still NAD goes up in the tissue.
Yeah, some people, thought, maybe gut bacteria takes it for themselves.
Yeah.
And that kind of lowers amount of NAD plus you derive from supplementation. But I think it just basically shows that, there is it's more complex. It's not as direct like we mentioned. But the good news, it goes up.
And this is the precursor, like spoiler alert, this is the precursor that you and I take. We take about a gram a day with our first meal of the day in the morning. And we're going to get to why in the morning. But now, what about NR? Because I know you've looked into the data very closely there. We were definitely very interested in NR in the early days. So what about NR?
Yeah. We even had a time of NR, basically ingredient centered. NR has the most clinical evidence, over 30 human trials. It requires 2 enzymatic steps, which are NRK1 and NRK2. Through processes, it becomes NMN. Then NMN becomes NAD+. A crossover study showed 1,000 milligrams daily raised blood NAD+ by approximately 90% in 2 weeks.
That's crazy. So 90%. Remember, we one UV, one UV, major UV exposure lowered by 90%. This is like 90% over 2 weeks, which is incredible. So that obviously that's very dramatic. So why would someone choose NMN over NR or vice versa?
So it's really, really great question. So it's all about tissue distribution. Animal data suggests NMN elevates NAD+ across a wider range of tissues, which are basically muscle, brain, kidney, vasculature, and R concentrates more in the liver and blood. For skin, which receives precursors through dermal blood supply, systemic levels matter, but NMN's broader reach may be an advantage.
Got it. So, and then there's niacin, right? So $5 at your local CVS. So what's the deal breaker there? Like, why are we talking about these 2 precursors and not niacin?
Yeah, I mean, niacin tried to make itself viral for NAD+ supplementation. And I mean, definitely biohackers on the budget, I think most of them tried it because there is a pathway, right? But the deal breaker would be flushing. So about 50 milligrams, niacin triggers what's called GPR109A receptor activation and prostaglandin D2 release. So it's intense skin redness, warmth, itching. I've seen you go through that, and it looks scary because he just turned all red, was hot, was itching everywhere, and Amitai gets allergies from time to time, so he's used to itching, but that was like crazy. I mean, most people find it intolerable. It also raises liver enzymes at sustained high doses. So that, you would have to then go and mediate that. It's not practical for targeted NAD+,
repletion. So it's more
replenishment.
I do take it when I go into the sauna. That's a different story. So
no, I know you don't take it for the NAD+ raising, as a supplement. But I just, I've seen you go through this flash, and I know other people have. And
so the story is this. I just want to say, the story is that I drank a shake and took niacin, and I guess my gut wasn't into digestion, basically. So it didn't digest. And then I went to the sauna, and after that I had a meal, and that that broke down the niacin. Like my gut broke. So it was outside of the sauna already. So that's why it was unexpected. But anyway, here's my hot take. NMN hot take, honest take. Okay, NMN is my first choice for broad spectrum NAD support. We both take, as I said, 1 gram daily or 1,000 milligrams, the same thing, with our first meal. NR is if you want the deepest safety data set, or the reason I want to emphasize that NR is a patented form, so there is more incentive by a specific company to research it. That is why when I say, there are many studies you know there is the most data about safety, it's because other studies could be biased for that matter. The fact that there are 30 studies, there is a higher incentive in researching it. However, we know it's safe. Niacin is, I would say, if you're on the budget, if you want like basic B3 sufficiency only, so at lower dosages, mainly to replenish B3 and take it within the recommended daily doses. And take it under doctors, with your physician.
One thing I'd add is that high-dose precursors increase nicotinamide flux, which can strain your methylation pathways. So to alleviate that, consider stacking TMG, trimethylglycine, at 500 milligrams as a methyl donor.
So basically a 2-to-1, we say a 2-to-1 ratio, which means, let's say that's what you said about 500 milligrams. So in the case that you take 1,000 milligrams of a precursor, that would mean that you should take TMG or another methyl donor at about 500 milligrams, right? And by the way, great product to take in general, trimethylglycine, a lot of studies behind it. But yeah, so this episode was kind of the first part of our deep dive nerding out about a molecule that we love, and we feel that since it's becoming extremely popular, even in skincare right now, there are nuances that we want to cover. So that was more of an intro. We talked about what it is, what it does in your cells, etc., which was great. In our next episode, we're going to talk more about, the applications of it in skincare, which is a whole different challenge as far as like absorption, formulation, stability,
definitely.
Delivery.
Lots to unpack there.
A lot to unpack. Different, we talked about TMG as something that you want to take with it in skincare. Completely different set of ingredients you want to...
Supportive ingredients,
exactly. So
stay tuned for part 2.
Yeah, and thank you everyone for listening. We hope it was enjoyable, and we'll see you here next time.
Bye.
Bye.